Hello everyone, I am Shivam Pinde, member of Team Geek Velocity. I'm here presenting you the prototype for the problem statement development of an AI-driven chatbot for INGRES as a virtual assistant. So, first of all, let me give you some context about the problem. The problem is that uh, the data published by INGRES currently is quite large and it's quite challenging for user to actually navigate through, which restricts the user from retrieving historical data due to large and complex data set. So here is where our solution kicks in. So proposed solution. Jal Sathi is a conversational assistant integrated with the English database. It understands natural language queries and generates precise responses by automatically detecting the user role. The system adapts its answer for different users by switching between specialized response forms. What our solution does is it integrates with the existing database of INGRES and using that using the data from the database, it provides valuable insights to the user of different categories, that is general public, planners, policymakers, and researchers. We'll see it here now. So as you can see, this is the chat interface, minimal and intuitive. So here you can see we ask the query, yes, how does salinity in Bhatinda's water affect my crop and what can I do about it? So it's a general public query. It's asked by a farmer. So here we can see what response we have got from the chatbot. Look, let's look at what the data says for Bhatinda. Our records show the groundwater here is officially saline. This high salt content can stress your crops, making it difficult for them to absorb water and nutrients, which often leads to stunt growth and low yield. The challenge is with low average rainfall, there is a heavy reliance on groundwater for irrigation. This can cause salt to build up in your soil over time. To combat this, consider planting salt tolerant crops like barley, cotton, or specific wheat varieties and improving field drainage to help flush salt away. So as you saw, firstly it answered the query that what is the salinity, how does salinity affect the crops of that particular farmer in Bhatinda. So it answered it in the first part and what can he do. So you can see it provided valuable insights like include plant tolerant crops like barley, cotton, and other specific wheat varieties. And it also suggested him that improving field drainage will help him combat this situation. Now we'll ask another query. Yes. So now this query is asked by a policymaker. Should Bhatinda implement stricter limits on industrial discharge to prevent groundwater pollution? Typical query by a policymaker. So we see what response we have got. Hi there, great question. Looking at the ingress data for Bhatinda, the numbers certainly point towards the need of action. Here, the breakdown, the stage of extraction is a key indicator showing how much groundwater is used versus what's naturally available. For Bhatinda, this is critical 145%, meaning the groundwater is overexploited and being used much faster than it can be replenished. While industrial extraction is high, we are also seeing that 1% of water samples show quality issues in an already stressed system. Any contamination is a serious warning sign. Therefore, implementing stricter industrial discharge limit would be a proactive step to protect this vital overstressed resource. So as you can see, it provided a policy maker specific answer for this query. You can see both the queries were about Bhatinda, but the way of answering it for different categories of users were different. So now let's ask another query. But now, as a planner, how can urban planning in Bhatinda incorporate groundwater recharge zones to combat overexploitation? So here's the response. That's a crucial question for Bhatinda's future. The data shows critical situation stage of groundwater extraction is 145%. In simple terms, this means every 100 liters of water that naturally depends on the ground, 145 liters are being taken out. But here's the good news. For planners, Bhatinda's block has 90,000 hectares of recharge worthy area. This is a massive opportunity. Urban planning can directly combat over exploitation by zoning these areas as special groundwater recharge zones to limit heavy construction, mandating rainwater harvesting and permeable pavements in a new development within these zones, creating green belts and revitalizing ponds to help rainfall seep into the ground naturally. Focusing development efforts on these key areas can make huge difference. You can see what a chatbot has done is it has extracted the data from the INGRES database and used its own knowledge base to actually answer questions regarding the query asked. Like for planners, it has suggested what would be done. For policymakers, it has suggested what issues are actually worrying, and for farmers, it has suggested what can he do to actually tackle the problem of salt building up in his field. So as you can see, both of these, as you can see, all three of these queries are different and asked by different users. So you can see the intent and the role of every user was auto-determined by the chatbot, and valuable insights were given using the INGRES database and the knowledge base used by the chatbot. So by this by this system, we can actually bridge the gap between different categories of users and vast database. So this is a solution. This is the home page. This is about real-time data, smart irrigation, conservation tips, smart planning, expert support, data insight. So this is all from this side. Thank you.